Good afternoon. Uh, Resuming where we have left off, okay, and we were working with absolute value, going back to not only equations but also inequalities. And again, we have in our cases, again, if you have a non-negative value k, non-negative as where the value is 0 or higher. Okay, if we have that the absolute value of x is equal to k, then we have that x is equal to positive or negative k. And where the inequalities come in, and I decided to add a few more details about this. And we have in the first case regarding inequalities, if we have that the absolute value of x is less than k, then you're going to have the resulting compound inequality whereupon negative k is less than x is less than k. And this is just taking a synthesis of where we have simultaneously that x is greater than negative k and that x is less than positive k. And again, you have the resulting interval with negative and positive k in parentheses. And we have for the absolute value of x is less than or equal to k. You have also another resulting compound inequality, and this is the logical combining of where we have that x, the same x, is greater than or equal to negative k and is also less than or equal to positive k. Thus, we have this next compound inequality statement, and we have the terms negative and positive k enclosed in brackets for the interval notation. And finally, we have for the cases where the absolute value of the expression is greater than or equal to k, you'll have inequalities that will be going in opposite directions upon removal of the absolute value terminology. And this is where we have at the extremes, you have the x is less than or equal to negative k, depending upon how the inequality in the absolute value is established, or it could be at the other end of the spectrum where x is greater than or possibly greater than or equal to k. So you have like polar opposites in these last two cases. And touching upon the linking words that we have with or as well as and we have from section R8, okay, and this deals with the terms or and in what we have for section R8. Whenever you're looking at inequality statements here, okay, that are combined by the word and, okay, you're looking at what is shared between the inequalities. All right, now in terms of the word or, you're looking at combining all the elements. In other words, combining everything. Consolidating, in other words. Okay, so combining everything, regardless of whether the items are shared or not. Okay. Let's say we have from the inequalities. And where these terms are presented, and we have from section R.8, and we have in the case of number 27, and we have two individual inequality statements, okay, where we have the x is less than 4 and also where we have the x is greater than or equal to negative 2. And just presenting a bit of a visual Okay, so I have x is less than 4 and x is greater than or equal to negative 2. And what I'll do here, I'll just put up both of these numbers. Okay, so I have negative 2 and 4. Okay, so we have in terms of the activity. Okay, so we have for x is less than 4. Okay, so 4 is not included, but everything in x that is less than 4 is involved. Okay, so as a graphing indicator, we have an open circle on 4. So the openness indicates that 4 is not in the mix. And we have all the values of x, okay, to be less than 4. And okay, so I have a ray that's going out to the left. So this is representing x is less than 4. Now for x is greater than or equal to negative 2. Now with the equal sign, negative 2 is included. So we're going to have not an open circle, but a close point at negative 2. So that part we have with the x equal to negative 2. Everything else is going to be greater than. And so we're going to have a ray that's going to go in the other direction. Now, with the relation between these inequalities, okay, if we're trying to look at determining what values will belong whenever we say that we're looking at those values of x such that x is less than 4 and x is greater than or equal to negative 2. Okay. Right, now with the word and, you're looking at what will be shared between the inequalities. In other words, what elements will belong to both x is less than 4 and x is greater than or equal to negative 2. Okay. So we have in this particular setup, okay, so we're looking at what will be shared in common. Okay, so if you notice at the lower end, okay, we cannot go any lower than negative 2. So the very minimum on the left-hand side is going to be negative 2. And for what we have in terms of the maximum, okay, now you have, like for this particular ray, have going continuously out to infinity. But for the first inequality, the graph only goes to highest, like 3.99999, as indicated by the open circle. So we cannot have anything in terms of commonalities. There cannot be anything that goes to 4 and beyond. So we have the upper limit, okay, to be with the indication or indicator with the open circle at 4, and everything else in between is going to belong in this set. Yeah, so instead of a ray or a line, okay, we're going to have, once again, we're going to have a line segment instead. So I'm going to get my character to show up. There we go. So you have the line segment. Okay, and for what we have in this case, for x is less than 4 and x is greater than or equal to negative 2. Okay, notice if I consolidate, okay, what is in common? So we have the lower limit is at negative 2, and we have x to be between negative 2 and the open circle at 4. So you have like negative 2 is going to be less than or equal to x, and x in turn is going to be less than 4. So again, just consolidating these terms as a compound inequality. So we're going to have that negative 2 is less than or equal to x, and x in turn okay, is going to be less than 4. And for the interval solution in this case, all right, so you have between -2 and +4, -2 is included, so that will be in the bracket, and with 4 not quite included, okay, that's going to be in the parenthesis. Now, where we have x is less than 4, or x is greater than or equal to -2. Okay, so you're looking at putting everything together. Okay, so before we had an open circle at 4, an array going to the left. And everything from this set, okay, is going to be included in the OR statement. And also at the same token, everything from -2 on out to the right, that is also going to be included. You have a close point. And we have with the array going out to the right. And guess what? Where 4 was left out from the first graph, or the first inequality description, it's going to be included because 4 is part of x is greater than or equal to -2. So we'll be able to close out 4. And guess what? For what we have in this particular setting, we have going continuously from end to end with what we have with the entire real number system. And the interval notation for the real number system, we have continuity between negative and positive infinity. And once again, infinities are boundless. And so these limits will remain in parentheses. Okay, so with the word and, you're looking at just the elements shared between the inequalities. Okay, and so you have -2 is less than or equal to x is less than 4. But with the word or, you're combining everything regardless of whether anything is shared or not. And we have now in the next case, for number 28, okay, we have going from the variable x to the letter y. And for the first one, okay, now we have that y is less than or equal to -2. And so for what we have here, I'm just going to reinsert this graph and change the numbers. Okay. And the numbers we'll be dealing with, we have -5 and -2. So for what we have at the start, we have y is less than or equal to -2. And thanks to the equal sign, -2 is included. And everything else, okay, is going to be less than. And we have with our other inequality, so we have that y is greater than -5. And for what we have in the case of y is greater than -5, now -5 is not included. So you have an open circle, and there will be a ray that will go out to the right. Okay, so you have these separate modes of activity. All right, now in terms of the words linking together the inequalities. Okay, so if I have that y is less than or equal to -2 and we have that y is greater than -5. Again, with and you're looking at what will be shared in common between the inequalities. Okay, so for what we shared between the inequalities, okay, so we're not going to have anything to the left of the open circle in -5, nor will we have anything to the right of the close points at -2. We have only these limits and everything else that lies between. Okay, so we have yet another line segment. Okay, and so we have just piecing together and rank ordering from smallest to largest. So you have -5, again, still not included. We have is less than x, and the close point at -2 indicates that we have x to be less than or equal to -2. So we have for the logical equivalent of combining these two statements into one. Okay, so we have that -5 is less than or equal to y. Right, that -5 is less than y. And in turn, we have that y is less than or equal to -2. And looking at, once again, with the word or, okay, so we're putting the sections together. Okay, so you have everything from -2 and to the left will be in the mix. And everything to the right of -5 is also going to be included. And guess what? Everything to the left of -2 is included, and that's going to include -5. And guess what? For what we have in the overall picture, everything between -5 and -2, to the right of -2 and to the left of -5 is going to be included. So in effect, what we're going to have all together will once again be the entire real number system. And we have for the respective intervals. Okay, here we have -5 is less than y is less than or equal to -2. Okay, so you have the numbers -5 and -2, so we have a parenthesis around -5 and a closed bracket around -2. And once again, we have combining both sets. Okay, we come out to the entire real number system. And once again, we have with the interval notation, so we have between negative and positive infinity. Okay, now in looking at what we have in crossing over to looking at solving for absolute value inequalities, and I tell you what, I'm going to duplicate these rules of thumb here. Okay. Now, in the crossover, and we have referencing, okay, section R.8, and looking at what we have in the case solving for the variable. And if we take what we have in the case number 48, and we have looking at solving for y, okay, and now we have in the presentation, okay, so we got 2 times the absolute value of 7 minus y, followed by the addition of 1 is less than 17. Okay, and again, we have the absolute value of 7 minus y, and again, do not treat the absolute value bars as you would parentheses. Okay, so we're not going to distribute 2 over the absolute value of 7 minus y. This absolute value term, again, we're going to isolate. And in the process, okay, so I can begin by undoing the addition of 1 by deducting 1 from both sides. So I'm going to have in the adjustment, okay, so I have 2 times the absolute value of 7 minus y is going to be less than 16, and taking care of the 2, so I'm going to undo the multiplication upon dividing both sides by 2. And if you notice, okay, I'm dividing both sides by a positive constant, so the direction of the inequality is fixed, so there's no change. Okay, and we have upon dividing, so this comes down to the absolute value of 7 minus y is less than 8. Okay, so I have an absolute value term, and I have that which represents k on the other side. Okay, so you have the absolute value of x is represented by the absolute value of 7 minus y is less than k, where k is represented by 8. So this would be an application of this particular case. Right, and we have rewriting upon removing 7 minus y from the absolute value bars. And we can put this between the numbers that have an absolute value of 8. Okay, so you have between negative 8 and positive 8. Okay, so for what we have here, okay, so if we look at isolating the y, okay, so we can undo the presence of 7. And taking 7 away from both sides, okay, so we have negative 8 minus 7, so this becomes negative 15. And we have that negative 15 is less than negative y, which in turn is going to be less than 1. Okay, now again, I'm not solving for negative y, but for y instead. Okay, so if I multiply or divide by negative 1, now just multiply by negative 1, so I'll be changing the signs. Going from a negative to a positive, and vice versa. And again, if I multiply or divide by negative, these inequality directions are going to change. In this case, from both that are expressed as less than to where we have greater than. Again, have the directional change again. And so for what we have in the adjustment, okay, so we got negative 1 times negative 15, so this will be a positive 15. We have the 15 is greater than y, and y in turn is greater than negative 1. Okay, so just retooling this and maintaining the logical consistency, expressing in order from smallest to largest. So we have that negative 1, y is greater than negative 1, same as negative 1 is less than y, 15 is greater than y is the same as saying that y is less than 15. And so this is going to be the inequality solution. And just kind of a quick visual, like -1, +15, and on a graph you would have open circles, and the values representing y, okay, will be represented by the line segment connecting those circles. And in the case of the interval solution, okay, so you have parentheses that will enclose -1 and +15. Okay, so this is quite a bit of a process, since we had a compound inequality and also where we had some sign changes that were involved. Now, if we have, say, in the case of number 58, okay, so this time we're going from solving for y to solving for d, and in this setup, okay, so we had that 15 is less than the absolute value of -2d minus 3, followed by the addition of 6. So just looking at what we have here, I'm just going to duplicate this. Okay, so I have the absolute value term on the right. Okay, now I'm going to isolate this upon taking 6 away from both sides. So we've got 15 minus 6. Okay, so we have 9. It's going to be less than the absolute value of -2d minus 3. And just maintain the logical equivalence. 9 is less than the absolute value of the expression is the same as saying that the expression is going to have its absolute value to be greater than 9. So I'm just kind of switching the order with the absolute value term on the left. Okay, so in this case, all right, I have like an example of a case where I have that the absolute value of x is greater than k. We have k to be represented by 9, and for this type of setting, if the inequality is such that the absolute value term is greater than the constant, then we have separate inequality statements, one that we have increasingly negative and also where we have increasingly positive. So we have for the opposing ends of the spectrum, in terms of what could be the situation for -2d minus 3, it could be where it is less than -9, and for almost like the polar opposite, it could be where we have -2d minus 3 is greater than 9. And looking at solving for d in these inequalities, okay, so if I isolate the d term, I can undo the subtraction of 3 by adding. So we have -2d is going to be less than -6. And again, where a bit of concentration is required. So we have upon dividing by the coefficient -2, we'll have the direction of the inequality to change. And so in this case, we're going to have that d is going to be greater than 3. Again, for our statements in comparison to 9. All right, so if I add 3 to both sides, okay, so we're going to have that negative 2d is greater than 12. And again, we have history to repeat with the division by negative 2. And again, division by a negative leads to, once again, switching the direction of the inequality. And in this case, okay, we're going to have that d will be less than negative 6. Okay, so you have 2 destinations possible for d, where d could be greater than 3 or it could be less than negative 6. And so for what we have, looking at sort of illustrating what we have possible for d. Okay, so we have the numerical values in the comparisons with negative 6 and 3. And for d is greater than 3. Okay, so 3 is not included, so we have an open circle. Greater than, we have a ray that's going to go out to the right. For d is less than negative 6. Okay, there's no equal sign, so negative 6 is not included. And for less than negative 6, okay, we have a ray that's going to go continuously to the left. Okay, so these sets are apart from each other, and writing out, okay, what we have for the interval solutions. Okay, so looking at it from the smallest to the largest values. Okay, so we have at the left end, we have the extreme minimum. Okay, we have right at negative infinity. And you have approaching but not including negative 6. Now, so we have for d greater than 3. Okay, so we have parentheses around 3, since 3 is not included. And the upper limit, okay, we have at infinity, so you have a parenthesis around that one. Okay, so we got for these, okay, we have parentheses exclusively. Again, since neither negative 6 nor 3 will be included, and also since infinities are going to be boundless. All right, now for what we have in the case of inequalities, and just sort of stepping back a little bit, and we have in section R8, okay, we have also with number 49, okay, and we're looking at solving for x. Okay, so we have 2 times the absolute value of x plus 3. Okay, we have followed by the subtraction of 4 is greater than or equal to 6. And so we have with this statement, so I'm going to isolate the absolute value of x plus 3. So again, I'm not going to distribute over the absolute value terms. Okay, so if I isolate the absolute value of x plus 3, I can initiate the process by adding 4 to both ends. So we have 2 times the absolute value of x plus 3. This will be greater than or equal to 10. And we have upon dividing both ends by 2. Okay, so I'm dividing by a positive, and so the direction of the inequality remains greater than or equal to. Right. And so narrowing it down, okay, so we got the absolute value of x plus 3 is greater than or equal to 5. Okay. And again, if the absolute value inequality is such that the absolute value term is greater than or equal to the positive constant or the non-zero constant, the non-negative constant, okay, you're going to have 2 opposing inequalities. Okay, where in the case of x plus 3, it could be increasingly negative, where we have x plus 3 is less than or equal to negative 5. Or it might be that x plus 3 will be increasingly positive, whereupon we have that x plus 3 is greater than or equal to 5. for the first situation, okay, so getting x by itself, and we have upon taking 3 away from both sides, so we have the x is less than or equal to -8. And for x plus 3 greater than or equal to 5, okay, so if I take 3 away, once again, and we have with this statement, okay, we're going to have the x is going to be greater than or equal to 2. So for the outcomes, potentially for x, either x will be less than or equal to -8, or it is going to be greater than or equal to 2. And just setting up what we have for interval solutions. Again, so we have the numbers concerned. We have at -8 and +2. Again, both -8 and 2 are included thanks to the equal sign. And in terms of the direction, so for less than or equal to, so we'll have a ray going out to the left. And for x greater than or equal to 2, okay, we'll have a ray that's going to go out to the right. And just expressing the result in terms of interval notation. Okay, so going from the extreme left to the extreme right. Okay, we have going from -infinity, approaching and including -8. So -8, okay, is going to be in the bracket. Okay, we have the union with the other interval section. So we have going from and including 2. And for the rest of the activity, we have going out to infinity. And this will be your interval solution. And we have 2 separate sections thanks to the disjointed elements from the separate inequalities. And now, for what we have in the case of number 52, okay, this one is going to serve a bit of small but yet significant reminder. And for what we have in the case of 52, you know, we have the statement, we have the absolute value of 2x plus 7 plus 5 is less than 1. Okay, so I don't have any coefficient in front of the 2x plus 7, and the only operation I'm going to perform is deducting 5 from both sides. Okay, so for what we'll have here, upon subtracting 5, we got the absolute value of 2x plus 7, and that is going to be less than -4. Okay, and for what we have got, okay, we got the absolute value of x represented by the absolute value of 2x plus 7. Now we have that k is -4. But again, just going back to our fundamentals, okay, that which represents k should be a non-negative value. So k can be 0 on up, but it can never be negative. And so for what we have in consequence, okay, is that because of the negative sign, it's going to turn out that there will be no solution. All right, and I'll tell you what, just in the case of looking at solving for inequalities, now you might have an integer and a non-integer value in the mix. I tell you what, just for the next few moments, okay, tell you what, let's see what we get and find the interval solutions. we'll discuss these in the next few moments. First of all, okay, we'll see that we have negative 3 times the absolute value of negative 3x plus 2 is less than negative 42. And also, let's see what we get for x whenever we have the same expression, negative 3 times the absolute value of negative 3x plus 2 is greater than or equal to minus 42. Okay, for these items, okay, we had the same terms, but the inequalities, okay, we have not the same by any stretch of the means. And looking at what we have now, okay, so we've got negative 3 times, okay, the absolute value of negative 3x plus 2 is less than negative 42. Okay, so again, I'm going to isolate the absolute value term, okay, and in front of it is negative 3. And I'm going to remove the negative 3 by dividing. And again, if you divide by, multiply or divide by negative, okay, the direction of the inequality will change. Okay, so we now have the absolute value of negative 3x plus 2 is going to be greater than positive 14. Okay. And so just looking at what we have now, okay, so you have a case of where you have the absolute value of x is greater than k, and k is positive 14. And again, so if the absolute value has the inequality to be greater than or equal to, you'll be looking at isolating the expression upon removal of the absolute value bars, comparing with the negative at one extreme and the positive of k at the other. So we're going to have for negative 3x plus 2, okay, you're going to have separate inequality statements where we have at the lower end we have less than negative 14, and the other possibility is where we have negative 3x plus 2 is greater than positive 14. And isolating the negative 3x. Okay, so if I take 2 away from both sides, okay, so I'm going to have that negative 3x is less than negative 14 minus 2, which will be negative 16. And dividing by negative 3. So you have another run-in with either multiplying or dividing by a negative. And again, each time you do so, the direction of the inequality changes. And so we're going to have here for this statement, we've got x, which is going to be greater than, and negative over negative is a positive, so we have that x is greater than 16/3, or you could also write as x is greater than 5 1/3. Okay. Now for the other scenario where we have negative 3x plus 2 to be greater than 14, again, isolating negative 3x by subtracting 2 on both sides once again. So we now have negative 3x is greater than 12. Again, we have with division by negative 3, we'll have the direction of the inequality to change. And for what we have here, negative 3x over negative 3 becomes x, and internally we have 12 divided by negative 3, so we have negative 4. So we're going to have x is less than negative 4. Okay. And you know, so you can have some surprises, that some surprising turns of events that can occur. Like you start out with less than a negative in the statement, but the value of x could be greater than the positive, and you might have the polar opposite, where you have the statement to be greater than the positive, a positive number to start out with, and the outcome for x is where it is less than a negative value. So sometimes those situations can appear, and it does in this particular case. And for the activity in terms of finding out the interval solutions, okay, so we got negative 4, and we have like for between 5 and 6, but closer to 5, okay, you have that number 16/3. And for the occurrences, okay, so for x is less than negative 4, again, negative 4 is not included, and defining this second inequality that results, again, we have a ray that's going to go continuously to the left. Now for x is greater than 16/3, okay, so I have an open circle at 16/3, and for x is greater than this value, so we have from the open circle, we have to emanate, okay, a ray that is going to go out to the right. Okay, so we have here, okay, so you have these activities to occur. All right, and in terms of translating what we have in interval notation, okay, so you have at the lower end, you have those values less than negative 4, at the upper end, okay, have those values that will be greater than 16/3. Okay. And so that'll be the interval result for this first absolute value inequality statement. All right. Now for the next item, okay, whereupon we have same terms, but this time we have the expression to be greater than or equal to negative 42. And once again, to get the absolute value portion by itself, okay, we have division by negative 3. Again, we have with division by negative. Okay, the inequality flips. Okay, so this will come down to where we have the absolute value of negative 3x plus 2 is less than or equal to positive 14. All right, and again, if the inequality is greater than or equal to the constant, you're going to have these disjointed statements. And if the inequality is such that the absolute value is less than or equal to that which represents k, you're going to have a compound inequality, okay, where you have the expression inside that was inside the absolute value bars to lie between the negative and the positive k. Okay, so you have, in this case, you have negative 14 is less than or equal to negative 3x plus 2 which in turn is going to be less than or equal to 14. And so we have with getting x by itself, okay, so I can subtract 2. If I do it at one section, I'm going to do it at all sections. And so subtracting 2, Okay, so I have negative 14 minus 2. So this will be negative 16. And we have negative 16 is less than or equal to negative 3x. And 14 minus 2. Okay, this will become 12. And guess what? Translating from negative 3x, or converting from negative 3x to x, have division by negative 3. And both of these inequality sections will change directions. So for what we're going to have here, we have negative 16 over negative 3. Again, this becomes 16 thirds. 16 thirds is greater than or equal to x. And for 12 over negative 3, okay, we have it negative 4. Okay. And just rearranging what I have in the inequality going from smallest to largest. Okay, so you have negative x is greater than or equal to negative 4. It's the same as saying negative 4 is less than or equal to x. And for 16 thirds is greater than or equal to x, this will be the same as saying x is less than or equal to 16 thirds. And so, once again, we're going to have these numbers to arise Okay, so you have negative 4. And we've got 16 thirds. And for the activity, okay, so with the equal signs, okay, negative 4 and 16 thirds are going to be included. And everything else in between is also in the mix. Okay, so we have this line segment as a graphical solution, and for what we have for the interval, okay, so we're going from and including negative 4 out to and also including 16 thirds, and the inclusions will be indicated by brackets surrounding these limits. Okay, so you have a closed interval in this particular second case. All right, okay, so we have with inequalities, okay, have quite a bit of alternating among the signs. Again, if you multiply or divide by a negative, the direction of the inequality can change. And now, let me mention one more thing regarding absolute value inequalities. And we have N60. Now you can have absolute values of fractions, and 60 is such a case. And we have for this individual statement, we have that the absolute value of m minus 4 over 2 is less than 14. So you got absolute value of x represented by the absolute value of this fraction, and k again is represented by 14. So if the direction is less than or equal to, okay, once again you will have a compound inequality, and so k we have a 14, and removing the absolute value sign, we end up with negative 14 is less than m minus 4 over 2 which in turn, okay, is going to be less than 14. And then just taking care of the fractions, so multiplying by 2, so I'm going to multiply everything out by 2. And since I'm multiplying by a positive 2, the inequality directions will remain the same. Okay, so we got, so we have 2 times negative 14, so we have a negative 28. We had to be less than, we had the 2's going to cancel out, so this will leave us with m minus 4. And we have in turn is less than 28. Okay, so I have m minus 4 in the middle. And if I adjust this to where I have just the variable m, so moving the 4 by adding, and this will affect not only the middle but also the opposite ends. So 4 is going to be added throughout, and we have at each layer. Okay, so we got negative 28 plus 4, so we have negative 24 is less than m, and in turn we have 28 plus 4 is going to be 32, and so for what we have here at the extremes. Okay, so we got negative 24 is less than m is less than 32, and on the graph we have open circles at these locations, and the solution is going to be the line segment that connects those values. Okay, so it's going to connect the open circles, and so for the interval solution, okay, so you have between but not including negative 24 and 32, and around these numbers again will be parentheses. Okay, so you got another case of what we have with absolute value inequalities. Okay, now the other day, okay, or yesterday, I had given just like a set of review problems to be looking into, and just kind of glancing over just the first few, and in the group, okay, just like for those that will kind of carry over to not only this chapter but for other chapters as well. And again, you have working with multiplying binomial expressions. And we have for 32. Okay, so I'm looking at multiplying multivariable expressions. We're having the first, I have 5w cubed plus 6y squared. And we have times, and we have 2w cubed minus y squared. And if I look at FOILing out, okay, so you have first part, you have 5 times 2 is 10, w to the third times itself. You're looking at adding the powers together. So you got 10w to the sixth. Now for the outside, you got positive times a negative is a negative. So it's be negative 5 w to the third, y to the second. Inside product, so you have 6 times 2, so this would be 12 y squared w cubed. And if I arrange the variables in alphabetical order, so we have w to the third and y to the second, and we have for the last product, okay, so I have positive times the negative is a negative, and this will be 6 times y to the fourth. And again, okay, so combining the terms. Now the first we have as the only w to the sixth term. Now the middle two terms, they can be joined, where they have not only w and y but also the identical degrees in w and y. So I can add these together. So you got negative 5 plus 12 is going to make a positive 7. So I have 7w to the third, y to the second, and we have the last term is going to be the standalone y to the fourth expression. And so we have for the product, okay, this would come out to that particular trinomial. All right, now for what we have in the case of number 34, okay, And we'll be dealing with differences of squares quite a bit. Not only with the real and complex number sections in Chapter R, but kind of throughout the course. And so we have 9 times t minus 4 times the quantity of 9 times t plus 4. And if I FOIL out, got the first product, have 9t and 9t multiplied together. So this will be 81t squared. And you're going to have the outside and inside products to be additive inverses, meaning that they're going to cancel each other. So the outside product we have at 36t, and the inside product we have at negative 36t. And the last product we have negative 4 times 4, which will be negative 16. And again, the first order variable terms cancel, and so the product becomes the difference of squares, where we have 81 t to the second minus 16. And just kind of remaining portion here, and this kind of serves as a reminder. And we have for 46, if I'm looking at factoring, and also in the variable t, so I have 12t squared minus t minus 6. Okay, so we have with the first and the last coefficients, if I try guessing what the factors might be, it might take a long time to get to the right combination. Like 12t squared might be 12t and t, 6t and 2t, or 4t and 3t. And the minus 6 could be like plus 6 minus 1, minus 6 plus 1, and any positives and negatives between 3 and 2. And so it could take a while if you do like a bit of guesswork. So in terms of the factoring by grouping, okay, this can not only eliminate the guesswork but also save quite a bit of time. And so we have multiplying the first and the last coefficients. Okay, so I have 12 times negative 6 will be negative 72. And where the negative 1t comes in, I'll be looking at the factors of negative 72 that will add to negative 1. Okay, so before I had 12 and negative 6, but these numbers add up to positive 6, but I'm looking at a negative 1 sum. And negative 72 does have quite a few factors, and the combination that will add to negative 1 will be negative 9 and 8. And the negative 9 and 8 can be coefficients of our t terms that will be used upon splitting negative t. And again, it technically doesn't matter what order you place these, but I would have, if I have like a negative term and a positive term, again, I would have the positive term to follow the negative, where those situations arrive, such that the middle term or the middle operation between the groups is going to be addition. So I would not have to do any like factoring out a negative manipulation. So we have with this approach, okay, so we have 12t squared, we have with negative 9, so we have minus 9t, followed by plus 8t, and again we have minus 6 at the end. And crossing over to grouping, okay, so I have 12t squared minus 9t, and again the central operation, okay, we have addition. Now I'm going to go ahead and put in parentheses 8t minus 6, and for 12t squared minus 9t, okay, so I can factor out the greatest common factor. In this case, you have We have t, and also the highest number that will go into 12 and negative 9. That is going to be 3. So the greatest common factor will be at 3t and into 12t squared minus 9t. So we have 4t minus 3. And bringing down the plus, greatest common factor of 8t minus 6. Okay, so that is going to be just a number, and that is going to be at 2. And 2 will go into 8t minus 6, which will be 4t minus 3 times. And so for what we have, all in all, okay, so you have a shared binomial factor with 4t minus 3. And the other factor will stem from the outside terms and operation, with the greatest common factors and the operation outside at addition. So we have 3t plus 2. Okay, so those would be our two factors. You can always double check. 4t times 3t is 12t squared. And then we'll have plus 8t from the outside minus 9t from the inside, which will be negative t. Then we have negative 3 times 2, which will be negative 6. Okay, so we do have that manner of consistency.